Okay, great. Today we're going to talk with Bryan Larish, who's the Technical Director of Enterprise Networks at the NSA. And Brian's been doing a lot of work looking at various SDN technologies and their applications to government networks. So we're very lucky to get the inside scoop from Bryan today. So thanks, Bryan.
Yeah, thanks for having me. This is really exciting. As a former student of your course and going through all this stuff, this is kind of fun.
Cool. So, what would you say your job is in managing the NSA's enterprise network? Like, what kind of problems do you need to deal with on a day-to-day basis, and what do you find yourself doing daily?
Yeah, so that's a great question. So as technical director, my role is to look at the networks that we have today, look at problem areas, look at what industry and academia are doing, and see where we can apply new kinds of technologies or new approaches to solve those problems and sort of pave the way forward for the future of NSA's enterprise networks. And so as part of that, I get to see a lot of the problems that we have and places where we can improve. So on a day-to-day basis, it's looking at those problems, looking at the technology, and figuring out how we can incorporate those kind of things into the network.
Ah, cool. So I guess it sounds like you're looking at a bunch of new technology these days, right?
Yes. So when we look at today's technology, so some specific kind of problems we're trying to tackle right now, and I don't think this is unique to the NSA. I think pretty much every large enterprise that I'm aware of has these problems. But managing these large enterprise networks is really, really difficult with the tools we have today. And I think that's for a couple of factors. One of them is just the diversity of users that we have inside of our network. And so I think a lot of enterprises will run thousands of different applications inside of their network, right? And each one of those applications requires something special from the network. There's not a lot of uniformity. And that in itself is a management problem, but when that kind of thing comes to me, the network guy, I then, to implement that special thing the application needs, I have to go touch lots of different boxes in my network one at a time, putting one-off, very specialized configurations, setups on those boxes. And so you can imagine if I have thousands of applications, let's just say hundreds of boxes, lots of different boxes, that's a lot of individual configurations, a lot of opportunity to make errors, makes it hard to troubleshoot. It's very hard to predict what those changes are gonna impact or how they're gonna turn out. So this space today, it's hard to deal with that with the existing tools, right? This is just a flat out numbers problem that we have today, and so existing technology doesn't really help with that. So we're looking at lots of new things. You know, for example, with SDN and this notion of centralized control, maybe now if I have to do lots of one-off things, I can go to one centralized point in my network, make the changes there, and have some confidence that I know the impact of those changes and that those changes will be propagated to my entire network the way I expect. So the things we're seeing today, the problems we're trying to solve are just really hard to tackle with technology we have today.
So you think that SDN is going to help you kind of tackle the challenges with heterogeneity a bit better and the diversity?
So that's a good question. On the application side, I think it's going to be hard for us to do anything there, right? As an enterprise, we're always going to have huge diversity and heterogeneity in the applications that run on our networks. I think all enterprises are going to be like that. But within the network, I think SDN has a huge promise there to help with that management challenge, where if I have a centralized point of control, there's just a lot of things I can do that are very difficult when I'm trying to individually put configurations and settings in lots of different places across my network.
So it sounds like, I mean, a lot of it is sort of reducing the cost of operations for things you're already doing. Is that fair to say, or you think there's sort of new things that you also want to do that are just way too hard right now, or is it a combination of the two?
So I think it's a combination. Being any good large enterprise, we have lots of processes and budget planning and those kind of things. And so getting our foot in the door to do new stuff is easiest when we can go in and say, hey, we're going to reduce the operational costs. And so there's huge value in reducing the operational costs. That lets us get new technology started and moving. But at the end of the day, our long-term goal is new capabilities, right? That if new capabilities weren't possible, I'm not sure we would be looking at SDN and these kind of approaches as strongly as we are.
Mm-hmm. What do you think is like the single biggest missing piece of functionality that you want to see addressed, like that you think SDN can help with?
Wow, you're asking me the hard ones, huh?
Yeah.
So let me answer that, but maybe not in the way you were thinking. So when I look at enterprises today, the applications and the workloads that we run on our networks are very different than when the internet first started. So if you look at something like the Department of Defense or NSA, we have time-critical applications that have to work, otherwise people's lives might be in jeopardy. If you look at a large bank or a large financial institution, it's a similar kind of thing where applications have to work, have to behave the way they expect, otherwise people lose lots and lots of money. And that's totally different than when the internet first came about and it was ad hoc, let's have people come together and share files and emails. Mm-hmm. It's important they get there, but there's not this sense of urgency. And so the biggest piece of functionality I want is a network that is built for those kind of mission critical, have to have applications with dependable performance and predictable outages, and for that kind of environment, as opposed to let's build a network that just lets everybody come and communicate with sort of a best effort, kind of service, and whoever wants to come and play can come and play.
Sort of a really high assurance, high reliability guarantees, and as opposed to just a best effort kind of model.
Yeah, or maybe the ability to, in the cases where I need high availability and guarantees, the ability to ensure that with the network. So we don't necessarily need that everywhere, but on the places we need it, we need to be able to enforce it, ensure that it's going to happen, and guarantee that level of performance.
Mm-hmm. I see. So it's funny because it's sort of like, in a way, kind of tracing the internet all the way back to its roots, its survivability, except it's not in the same sense that it was originally envisioned, of like, A needing to talk to B in spite of arbitrary failures, but A really having good assurance and performance guarantees when it's talking to B.
Absolutely. And I think it's a great testament to how sort of the designers of the internet and those pioneers developed it, is that the internet has morphed into that initial intent, and now people are trying to take it and use it in all these different ways. I think that's outstanding. We're just trying to figure out, how can we do these new ways possibly better with a new technology approach.
Mm-hmm. Mm-hmm. So I guess like another thing that you probably deal with in your role as a technical director is a lot of legacy, shall we say, both in terms of equipment as well as expertise. For example, I guess you have like a large install base of hardware switches and things like that now that you kind of need to sort of figure out what to do with in terms of migration and things like that, and as well also operators, right, who are likely to say, yeah, we can do all that now with the equipment that we have. So how do you sort of are you facing those kind of challenges, and how do you sort of deal with both the capital and the human expertise transitions, if you will?
So it's not easy. I'll start on the technical side because that's got a little bit cleaner story. So the good news is that when you run a large enterprise network, You have lots of hardware that needs to be refreshed just kind of continuously, right? So if you have a 3-year life cycle on a network switch or a router, and you run lots of routers, you're pretty much replacing switches all the time. So from a technology perspective, we do have a huge legacy install base, but we also have great opportunities to inject new technology when we're doing hardware refresh. So that's the good part on that. The other kind of tact we've taken is if you look at any enterprise network, you sort of have out on the edges branch offices, campus networks, data centers, all connected to a wide area backbone that allows them all to communicate. And so the approach we've taken is start at the edges of our network and replace more or less isolated areas of the network with SDN that can operate sort of independently of the other ones. Mm-hmm. So maybe go to a single branch office, replace the entire network there. And as long as it can connect to the WAN backbone that we have, we're kind of good from a functionality perspective, and we can have SDN just in that isolated place. So we've taken that approach of like start at the edges of our network, replace around, and then as we get more comfortable with the technology, start looking at how we can replace in that core backbone.
That's cool. So like you have these sort of islands of SDN doing things at branches, and that allows you some ability to kind of test the waters.
Exactly.
I see.
Exactly. Without having to rip out every single, legacy device that we have, and right, that's just not a feasible approach. So it's nice because we can have these independent places where we can start replacing piece by piece, and then hopefully have the critical mass where everything can just be SDN.
Mm-hmm. Are you finding that like the operators who run the network are picking up the new technology with some ease, or I mean, certainly the sort of traditional network operations has not really involved writing programs, so there's a bit of a learning curve there, I imagine.
Yeah, so this actually has been a really challenging area for us, because a lot of times when the existing network operators hear about SDN, it's said in a way that they immediately think their job is going away. And right, if you think this certain technology is going to make your job go away, you're not necessarily going to be very receptive to learning it and figuring out how to use it. And so internally, we've had a pretty difficult challenge in getting the existing folks up to speed and participating in our SDN efforts, which is a shame, because what the thing we try to tell them is, your job's not going away, the skills you have aren't irrelevant, but we want you to do new things that make better use of your time, better use of your skills. So for example, I want somebody who understands how routing protocols work, right? So how OSPF works or Dijkstra's algorithm works, but I don't necessarily want somebody who knows how to configure that on a Cisco or a Juniper or Brocade router, right? I want somebody who has those network fundamentals, but can help us figure out how to implement that in a different way. So that's what we've been trying to tell them. On the flip side, we've actually been going to folks who would not traditionally think about networking as a career field or a career path, and telling them, look, here are all these great new opportunities, right? So if you're a software developer, we're trying to implement new things in software. Here's an opportunity to do new and exciting stuff that nobody else out there is doing, and you're just going to be applying that in the specific network technology area. That actually has been the most successful approach we've taken, because kids just coming out of college or who just graduated and starting at NSA, they want to do new, exciting, interesting stuff. And so SDN has been the perfect carrot, so to speak, to say, hey, here's something really cool that you can come work on that you probably never would have thought of.
Mm-hmm. And it's a good resume line item for them too. So.
Yes, yeah. So then we have the whole challenge of, once we have these SDN experts, how do we keep them around? But that's a different problem.
Right. But I like the point you made about sort of, the domain expertise is kind of indispensable, right? I mean, you kind of need both, right? You can't just take a software developer and have them, just write your new network control application. They need to know OSPF or BGP, or they need their networking fundamentals as well. So it's a matter of kind of adaptation, or at least for today's operators, right?
Yes. So you can't do it in a vacuum, and there's so many lessons learned from this entire history of the internet, right? And if you don't have that domain expertise, you're going to relive all those lessons learned in a very painful way. And actually, this was actually a funny experience we had yesterday. So we have a isolated place in our network where we're implementing SDN, and it's mainly for our SDN team, providing the day-to-day connectivity. So luckily there was no business or mission impact, but the folks didn't quite understand all the impacts of spanning tree, and they turned on an SDN application, and within a couple of hours the entire network fell over because we weren't handling spanning tree appropriately. Mm-hmm. Right? So that was the perfect example of, if we had the network engineer there who understood what we were trying to do with the SDN, they could have said, "Whoa, time out, guys. This is going to be not good."
Mm-hmm. Right. From that perspective, like, it seems like, with this sort of centralization of policy, and a lot of this is definitely promise there, but also, do you think you're going to need more software developers or more people? I mean, in some sense, are you taking money that would have been, shall we say, markup on certain vendor hardware and like throwing that at software engineers, or how do you sort of reason about that? Do you think you're sort of just creating a bigger software engineering enterprise, or how do you view that?
Yeah, so that's another really tough problem. So we have the challenge that when we tell our leadership about these potential cost savings, they look at the cost of legacy hardware and go, "Oh, well, that's going to reduce by 50%. I can just cut your budget by 50%. I'm not buying that anymore," right? and so we have to go, "Well, guys, time out, right? You can cut that part of the budget by 50%, but we're going to need to augment that or replace that with software developers, because we're now implementing the capability there." So it's definitely not a just cut all the hardware budget you had and use that money elsewhere. But what we don't know is how much of that software talent we need to have, right? So for every dollar of hardware reduction, is that a dollar of increase in software developer? I hope not, but what that trade-off is, right, we don't know. Is it for every $10 I lose on the hardware side, it's a dollar increase on the software developer side?
And hopefully over time that exchange rate will change, right? Because as the ecosystem gets more mature, there'll be more tools and more hopefully more software platforms out there that make some of these things a little bit easier.
Absolutely, right. So the promise of doing a lot of this open source, the same way server guys manage servers, I think is something where really hopes come to fruition, because that's, I think, one key way to get that exchange at a more favorable level. But even just expanding the marketplace in general, I think, will help, right? So I know a lot of people have talked about the way you have an app store for your iPhone or your Android phone. I want the same thing for my SDN controller. That's absolutely what we want, because I think that's really where you're going to see that exchange take the more favorable turn.
Mm-hmm. So what do you think about, I mean, in terms of like just the whole ecosystem as it evolves? I mean, even just like compared to a year ago, there are a bunch of technologies that were arguably there, but are much more mature now than they were a year ago, like Docker and OpenStack, and even controllers like Ryu seem to be quite a bit further along. How do you sort of keep pace with sort of the sort of rapid changes? I mean, on the one hand, it's good, right, because you have better tools to work with, but also maybe there's some integration challenges that you face.
Yeah, so I mean, to be honest, it's hard to keep up with all the things that are going on. There are just so many moving parts. It seems like every day there's something new coming out that people are asking, "Oh, did you see this or did you see that?" And so, to be blunt, I don't think we have a good answer at this point. The one thing we have tried to do is lay out a set of principles that we're trying to follow. So things like any new technology we do is going to simplify our network, or we're going to reduce hardware cost or operational cost, or we have these set of objectives. And so anytime we get something new, we're evaluating those against the objectives so we can make a relatively quick decision on whether we need to explore it further or just kind of put it off to the side. So that's at a first pass what we're doing. The integration question is a great one. And that's actually something that internally we're having a debate right now is what kind of role do we want to have there? Do we, the NSA, want to get a bunch of open source or proprietary components and integrate them ourselves? Or do we want to look to a third-party vendor to do that integration on our behalf? And again, I don't have an answer for you, but that's some of the thought process that we're going through right now.
In terms of cost savings and things like that, I mean, are there any particular functionalities or application areas that definitely look like a clear win? I mean, for example, containerization seems to be pretty talked about these days. Docker and OpenStack and some of these things. Do you see cost savings in your network as a result of things like that?
I think potentially. So for me, something like Docker or virtualization, the reason that would, in my opinion, where the cost benefit would be, is it lowers the barrier to entry for new vendors, right? So instead of a new vendor having to build a hardware platform from the ground up and then layer their network their firewall software or their IDS or IPS software on top, they can go right to the software layer. Mm-hmm. And so that I'm hoping that lower barrier to entry will increase the amount of innovation, the amount of companies in the marketplace, and that competition is what will drive the new capabilities we want and drive the cost.
And that's hopefully good for you, right? Like, as you said, it would hopefully drive down the cost, right? And also the switching cost, right, might actually be an important thing too, right? Because if all goes well, you could presumably swap out Docker container firewall A for vendor B without too much trouble. At least you wouldn't have to be swapping out hardware.
Absolutely. So that swapping out hardware is a huge problem for us. It is incredibly difficult to get new hardware deployed in our enterprise. And so I think, to your original question, the thing we're trying to do is commoditize every single bit of hardware we can, because it is just too timely, takes too much time, too costly to go replace hardware every time you need a new capability. I mean, just there's like the blanket statement that the IT infrastructure is too expensive and too slow, and a large part of that is because of the hardware. So we're hoping that commoditize every single bit of hardware we can, encourage the innovation and the new capabilities in the software level, and then that allows us to be more flexible and more agile when we want to do something new or we have to do something new.
Mm-hmm. In terms of just operational kind of tasks and things like that too, standard things like troubleshooting and access control and things like that come to mind. I mean, at the beginning you spoke broadly about sort of the advantages of sort of centralizing management. And certainly, at least in my own experience looking at operational configs, access control is just a huge beast in terms of both just the number of lines of config that it requires and the amount of changes that are happening all the time, and just the sort of overall complexity there. That seems like a kind of a beast. I'm wondering if that one's a particular problem for you, if you see sort of big wins in SDN there, or if there are other things that are bigger.
So I think for us and from the other enterprises I talked to, I think those two particular areas will be huge wins, because at least the way, in talking to folks, there's access control lists everywhere in the network. And if somebody has a new device or a new subnet that they need to put in the branch office or the campus, it takes a network engineer going in and modifying ACLs and making sure subnet masks are lined up on lots and lots and lots of different devices. And it's sort of like the stars have to align just perfectly for that new connectivity to take place. And inevitably, after the first pass of changes, they don't align perfectly, right? And then you have the application owners that were deploying the new system blaming the network people, and there's a lot of finger pointing because it's really hard to figure out where the problem occurred. And so, at least in our network operators' day-to-day business, I think the troubleshooting and the sort of ACL configuration would be huge wins for us. The troubleshooting goes beyond ACLs because every day we get outage reports on our network, and it's amazing to me how you see sort of outage happened here, and then we get periodic updates, and many times it's 6 or 7 iterations of people troubleshooting this or that just to find where the problem is, let alone how to fix it. And if you're having 3 or 4 people look in 6 or 7 different places to try to just find the problem, that's bad news, right? That there's got to be a better way.
Yeah, it seems like there's huge promise there. I don't know what the solution is, but
maybe some of your students in the class could take that one on.
I think so. Yeah. So I guess that would be my last question, which would be, given that you did a PhD yourself, and lots of students are likely watching, and hearing all kinds of great problems to work on in the NSA's enterprise network. I mean, what kinds of things do you think what would really impress you? Like if a graduating student came to you looking for a job, what could they say that they've worked on, or what problem would you like to see solved that would just really impress you?
So I'll give you just a general statement at first, and then we'll see if I can get creative and think of something specific. But especially for grad students, and especially for people who are trying to build their resume or find a new job, not necessarily people who are looking, at an existing company trying to figure out how to modify their product to make more money, because I think those are 2 separate issues. But the people who want to do something impressive on their resume, take a fundamental look at how networking is done today and try to find a way to do it better, right? So instead of putting a Band-Aid or somehow tweaking today's solutions, look at how to do it better. So don't give me a graphical user interface that lets me configure OSPF on a bunch of boxes from that one interface. Write me an SDN control application that says I don't have to use OSPF anywhere in my network, right? That's the kind of thing at least we're trying to do, is instead of mask the complexity in today's networks or make the existing way of doing business easier, we're trying to see, are there ways we can fundamentally re-engineer our network to actually just take the complexity out and get rid of it, so that we're addressing the fundamental issue instead of piling layers of abstraction on top of it.
So basically find something that is complex or hard, some problem that needs to be solved, and then think about how to sort of refactor, re-architect things such that you can take that complexity away, simplify, and remove complexity from the network.
Yes, that's exactly the kind of thing we're trying to challenge the people we have. And if somebody brought me a resume that said, here's a specific example of of them doing that, I would offer them a job on the spot if I was allowed to.
Yeah, it's definitely a good thing to work on, and it seems also almost anathema to the way networking has been done, where it's just checkbox after checkbox of feature. So it's even just working on simplifying is kind of a fundamentally different way of thinking about it. So
yes, yep.
Cool. Well, thanks for your time today, and we'll check back in a few years and see what's going on in your network.
Okay. Well, thanks for inviting me. This was great. So hopefully your students can start solving some of these problems, and in a couple of years we'll be light years ahead of where we are now.
Absolutely. Cool. Thanks a lot.
Thanks, Nick.